Hi guys, welcome back to the C# Basics series. Today we're going to be looking at jump statements. Let's get into it. So jump statements basically change the way that your code executes normally, and it's just easier to show it than talk about it. So we're going to start with creating an int, then we're going to create a while loop and then say while true is true. So this will be an infinite loop, and we'll do a console.writeLine of x. Right, so at its current state, this while loop will go forever because true will always be true, and the while loop will always go through. I'm going to add a console.readKey. I'm not going to run this because I know that it's an infinite loop, and C#'s even telling us that this code is unreachable. This will always be the only thing that executes. There's just this while loop over and over again. So we can go down here and say, if x is greater than 5, then we're going to break. And as you can tell, C# realizes that this code is now reachable, and it will happen. Not in its current state, though, again, because if you look closely enough, we're not iterating x anywhere. So I'm going to add that iteration at the end here, then go ahead and run this code. And you can see that we go through 0 through 5 for x, and then once we hit 5, we break out of the loop. So break is one that you use pretty often, and sort of in this way. Obviously you wouldn't probably ever have while true, but you'll have some sort of condition in the loop that'll check if this value is something or over something, then we want to break out of the loop and we're done. So there is another keyword called continue. This is definitely not as common as break, but it does sometimes have some uses that are fairly helpful and important to take note of. If we're going through this and we say I2 equals 0, and what this is this modulus operator. I talked about this on a previous episode. Basically it's saying if the remainder of I divided by 2 is 0, which means it's even, then we're going to want to continue. Then we're going to have a console.writeLine and print out I. So I'm just going to go ahead and run this and then talk about what continue does. So as you can see, while it's looping through, all of these numbers are odd. And so what continue does is continue will say if this condition is met, and we hit continue, it says ignore the rest of this for loop. We're going to ignore it and we're going to go to the next case. So if x equals 2 and then it hits this continue, it doesn't execute the rest of this code. It goes back up and it puts I equal to 3, and then obviously that's not even, so it doesn't hit this continue, and then it executes this console.writeLine. So continue will ignore the rest of the code in the loop. And the book talks about go-tos. Depending on your level of coding expertise, almost everything I've ever heard about go-to statements is bad. They're bad practice, not good. So I'm not going to go over them. I just don't think it's worthwhile, and it's bad like coding practice to sort of talk about go-tos. They just, from what I understand, make code less maintainable and just are not a good thing to have. So the next jump statement I want to talk about is the return keyword, and we've already used this a little bit with our good old friend the factorial method, which I'm going to recreate here. And so what we're going to do is say if n equals 1, then we're going to want to return n. Otherwise, we're going to want to return n times factorial of n minus 1. So the return keyword basically will stop the method from running. So if we're going to go ahead and call factorial, so we have to add the static keyword in for the factorial, and then I've just passed in 5 for this. And so we're sort of combining, oh, I guess I forgot to add in a print. So while we're here, I'm going to go and add a console.writeLine, and then print out n here. But then also after this last return, I'm going to go ahead and say console.writeLine and then print out unreachable. And just the point of this, again, C#'s telling us that this code is unreachable. This is the last return. So after the return, any code that's underneath it, it won't go to. Return stops the method from running and just gives back that variable. So we can go ahead and print this out. And then it goes backwards through our recursive function. So yeah, so when this if n equals 1 is met, we return n, and then it doesn't go forward. That's why this can work recursively, because this will return n, which is 1, and then it can go back up the factorial chain and then do the calculations. So basically the most important thing to know is that after the return keyword, no code below that will get reached. Finally, the last keyword we're going to talk about is something that's more advanced, talked about a little bit, is error catching. And so we're just going to say x equals null. Do I have to specify a type? Yeah. Okay, so we're going to say int x equals null. You can't logically do this, but we're not, for sake, we're not going to worry about that. We're not actually going to run this code. But you can say if x equals null, then we can throw a new exception. Argument null exception. So ignoring this code right here, basically what we're saying is that if x equals null, then we're going to throw a new exception, which is saying we're going to catch this error. This error would normally stop our program from running, but instead we're going to actually throw it, and we're catching this error, so that way the program can keep on running, but we can do things with this exception like logging and making sure that we're aware that this error is happening. And that is it for jump statements. Thanks for watching.